For the next several videos, we're going to be talking about the divergence and integral test. Let's start off with a couple of properties of infinite series that will come in useful while we're working with some of these tests. If the sum of the ANs equals A and the sum of the BNs is the infinite series, obviously AN and BN, equals B, and C is some real number, then the following series converge to the indicated sums. In other words, this infinite sum of C times AN is just going to be C times A. We've seen this sort of a thing again and again and again with limits and other sorts of things, so there really shouldn't be a surprise here. And also the sum of the infinite sum of AN plus or minus BN will of course be A plus or minus B. Now there's a third one I'm going to throw at you here, and I'm going to say this: if the sum n equals 1 to infinity of AN converges, so if this actually converges to something, then the sum n equals, I'm going to say, how about k to infinity of AN also converges. What this is saying is, if I remove a finite number of values from the series, they're still going to converge. If the whole series converges, then removing some values is not going to stop it from converging. That's almost a common sense sort of a thing, so I'm not going to bother with any proof to it, although there probably is a proof to this in your book if you want to look at it. Now, what these converge to may be different. This one may converge to one value, and this one converge to a different. Matter of fact, they probably would be different unless I was tossing away zero terms to begin with. But despite that, or regardless, the point here is simply that if the infinite series from 1 to infinity of AN converges, then from n to some other starting point to infinity will also converge.